November 12, 1942. Before sunrise, welders at Richmond shipyard rotate every 10 minutes. Part of a crazy new trick that turns the chaos of war into clockwork. 4 days later, the Liberty ship SS Robert E. Peary is launched, 230 days faster than anyone thought possible. With over 500 Allied ships lost to U-boats and supply lines in crisis, how did this 10-minute secret rewrite the rules of industrial warfare? The answer starts with a race against disaster. German U-boats prowled the Atlantic in 1941 and early 1942, hunting in packs and striking with deadly precision. Merchant convoys burned on the horizon. In just 12 months, more than 500 Allied ships slipped beneath the waves, torpedoed, shelled, or shattered by mines. 3 million tons of cargo vanished into cold water. Oil, tanks, grain, ammunition, lifelines for Britain, the Soviet Union, and the front lines were lost at a pace that outstripped all predictions. Each week brought fresh reports. Tankers sunk off Cape Hatteras, freighters lost near Iceland, supply columns broken off Nova Scotia. For the Allied command, the numbers told a simple story. The sea had become a graveyard, and the world's largest industrial power was suddenly on the defensive. The U.S. Maritime Commission, faced with the reality that existing shipyards could not replace losses fast enough, issued a sweeping mandate. The answer would not be found in tradition or caution. It would require a new kind of ship, one that could be built quickly, in huge numbers, by workers who had never set foot in a yard before. The Liberty ship was born out of this crisis, a cargo vessel designed for speed of construction above all else, stripped of ornament, engineered for mass production. The first of these, the SS Patrick Henry, launched in September 1941. Even as her hull slid into the water, the shipyard was still under construction, and the build took 150 days, far too slow to stem the tide. With each month, the gap between ships lost and ships built grew wider. The Maritime Commission's emergency plan called for thousands of Liberty ships, but at the current pace, the Atlantic threat loomed larger than any blueprint or promise. Every delay meant more convoys left unguarded, more soldiers and civilians cut off from supplies. The crisis was not only about steel and rivets, it was about survival. With the clock ticking, the nation's shipyards faced a single urgent question: how could they build faster than the enemy could destroy? Henry J. Kaiser stood at the edge of the bay in 1941, surveying a stretch of empty mudflats in Richmond, California. He was known for taming rivers and pouring concrete across the American West. Hoover Dam, Grand Coulee. But shipbuilding was new territory. The challenge was as big as anything he'd faced. Create a shipyard from scratch, then fill it with thousands of workers, most of whom had never held a welding torch. Within months, 4 massive yards rose along the shoreline. Railways and cranes crisscrossed the site. By the end of 1942, more than 90,000 people clocked in at Richmond: clerks, farmers, housewives, laborers from all 48 states. They poured in by the trainload, drawn by the promise of steady wages and a chance to help win the war. Kaiser's approach was direct. He tore up the old playbook and replaced it with a single rule: we can't wait for experience, we'll train it. The shipyards became a living laboratory. Training schools sprang up inside the gates. Instructors led crash courses in welding, blueprint reading, and safety, sometimes teaching a complete novice to handle a torch in just days. The workforce changed overnight. Women took up welding masks and gloves, while men who had never seen the ocean learned to cut steel. Supervisors, many borrowed from Detroit's auto plants, drilled teams in the rhythms of assembly line work. Speed mattered more than tradition. Ship sections were built in separate shops, then rolled out to the docks and welded together like giant building blocks. The scale was staggering. Each yard covered hundreds of acres, with sheds big enough to house a skyscraper on its side. Lights burned day and night. Cafeterias served hot meals around the clock. Childcare centers and clinics kept families close and absenteeism low. The goal was simple: get as many hands on deck as possible, keep them healthy, and move faster than the enemy's torpedoes. The experiment worked. In less than a year, Richmond became the beating heart of American shipbuilding. The yards could launch a new hull every few days, sometimes faster. The urgency of the crisis forced constant innovation. Every bottleneck became a puzzle to solve, every delay a lesson for tomorrow. By the time the SS Robert E. Peary was ready for her record-breaking sprint, the stage was set. A workforce of tens of thousands, an industrial city built from nothing, and a leader who believed that with enough training and teamwork, even the impossible could become routine. Riveting had ruled shipyards for decades. Each steel plate joined by hand, 2 workers on every seam, one inside, one out, hammering hot rivets through drilled holes. It was slow, loud, and relentless. Building a single Liberty ship meant driving more than 500,000 rivets, with each joint demanding careful teamwork and hours of muscle. The process was so specialized that only experienced crews could keep up, and every added rivet meant more weight and more time. But the war's demand for speed forced a break with tradition. Engineers turned to arc welding, a method that used electric current to melt steel plates together. A single welder could now fuse a seam in minutes, no rivet holes needed. This leap didn't just save time, it slashed the number of workers required at each joint. Where riveting needed 4 to 6 hands, welding often needed just 1 or 2. The change meant faster builds and lighter ships. Every ton saved could be filled with cargo instead of metal. Welding opened the gates for a new kind of workforce. Training that once took months could be condensed into days. Women stepped up to the torches, earning the nickname Rosie the Riveter, though by now she was more often Rosie the Welder. African Americans and migrants from across the country found steady work and a shot at fair pay. In Richmond, nearly 3 in 10 workers were women, and thousands more were people of color. For many, it was the first time earning union wages or working side by side with people from different backgrounds. The yards ran around the clock, and the learning curve was steep. Welders faced heat, noise, and the pressure to move faster with every shift. Fatigue set in quickly, especially on long, continuous seams. Supervisors tracked every minute lost to tired arms or botched welds. The need for a new rhythm, one that could keep welders sharp and the assembly line moving, became impossible to ignore. The solution would come not from the drawing board, but from the floor itself, as teams searched for ways to outpace both exhaustion and the enemy at sea. August 1942 brought a new kind of rhythm to the Richmond shipyards, a rhythm born not from the boardroom, but from the welding floor itself. Long seams had always been the bottleneck. A welder, hunched and sweating, pushed the arc as far as his arms could stand. By the end of a shift, fatigue set in, quality slipped, and the line slowed to a crawl. That summer, a welder named Edward L. Dong and his crew at Yard 2, Berth 3, started testing a different approach. Instead of grinding through endless feet of steel, they split each weld into 10-minute bursts. One man worked his section, then stepped back as the next slid in, torch already lit. The seam grew in quick, overlapping intervals, steady, relentless, never letting the metal cool or the crew wear out. Foreman C. Harriman watched the experiment closely. Dong's team kept pace, their welds smoother and more consistent. The difference was hard to ignore. On August 9th, a superintendent's memo authorized a formal trial. 10-minute weld cycles, staggered passes, each crew tagged by chalk marks along the hull. The shipyard's own newsletter, The Bosun's Whistle, ran a story on August 14th, showing Dong's crew lined up by their handiwork, welds marked with numbers and times, proof of a new tempo taking hold. The results were immediate. Welders finished their stretches before exhaustion set in, passing the torch with a nod and a joke. Downtime dropped. Heat stayed even across the plate, reducing the risk of cracking. Shop floor bulletins tracked the gains. Segment rotations slashed lost minutes, and incentive awards appeared for crews hitting 6 or more rotations per hour with solid joints. Word spread. By mid-August, superintendents debated yard-wide adoption if the pilot crews could shave 8% off hull assembly time. The name caught on: flash crews, moving with the speed and precision of a relay team. What started as a practical fix for tired arms became a blueprint for mass production. The 10-minute trick was no longer just a welder's shortcut, it was a system, and the numbers proved it worked. Steel plates arrived by the trainload, stacked in neat rows beside the slipways. In the sheds, teams of welders, fitters, and crane operators worked in a blur of motion, each crew focused on a single piece of the puzzle. Kaiser's yards didn't build ships from the keel up. They built them in sections, like a giant assembly kit. Bow, stern, deck houses, and bulkheads all took shape in parallel, then rolled out on rails to the docks. At peak, more than 150 prefabricated sections could be completed every day, each one tagged, inspected, and ready to be stitched into the hull. Production logs traced a staggering acceleration. In 1941, a Liberty ship took about 230 days from first cut to launch. By the summer of 1942, the average had dropped to just 42 days. By the end of that year, some ships left the yard in 17 days or less. The yards ran around the clock, every shift measured in minutes, not hours. Schedules were posted on chalkboards, with colored tags marking each segment's progress. Mistakes were costly, but the system left little room for delay. Crews rotated through stations with the precision of a factory line. The process was relentless, but strangely impersonal. No single worker built a ship. Instead, thousands contributed 10 minutes here, half an hour there. The shipyard became a living machine, its heartbeat set by whistles, horns, and the relentless tick of the clock. As each day passed, the numbers climbed. Hundreds of sections completed, dozens of hulls launched, and the gap between ships lost and ships delivered finally began to close. Before dawn on November 12, 1942, the Richmond shipyard braced for a spectacle. The SS Robert E. Peary, a Liberty ship assembled faster than anyone thought possible, was about to make history. Over 1,200 workers had poured their skill and sweat into her hull, trading off in 10-minute bursts, each crew passing the torch with barely a pause. The tempo never faltered. Welders, fitters, crane operators, and laborers moved in a relentless relay, their shifts tracked by a ticking clock and a string of chalk marks along the steel. From the first plate set to the final seam, the Peary took shape in just 4 days, 15 hours, and 29 minutes. Word of the attempt spread beyond the yard. Reporters arrived, notebooks in hand. Navy officials watched from the docks, some skeptical, others quietly hopeful. Crowds gathered, drawn by the promise of a new record and the roar of industry. When the last weld cooled and the Peary slid into the water, the yard erupted. Workers cheered, some waving their helmets, others hugging or laughing in disbelief. The feat was more than a number. It was proof that American workers, many new to shipbuilding, could outpace wartime destruction. Newspapers called it a miracle. Skeptics were silenced by the sight of a fully functional ship, ready for sea trials, built in less than 5 days by a team whose only secret was speed, teamwork, and a willingness to try something no one else had dared. Pride echoed through the shipyard, and for a moment the impossible felt routine. Cracks began appearing along the hulls of Liberty ships, sometimes thin as a hair, sometimes splitting steel wide open. In the North Atlantic, where winter waves struck like sledgehammers, entire vessels broke in two. Metallurgists pored over fractured plates, tracing the problem to the steel itself. Wartime shortages meant higher levels of sulfur and phosphorus, leaving the metal brittle in cold water. Welded seams, once the pride of the yards, became weak points when rapid overlapping welds left behind tangled patterns of residual stress. Each time a welder rotated out after 10 minutes, the next arc reheated the joint, creating sharp temperature swings. Microscopic flaws formed at these stop and start points, tiny cracks that could race across a hull under strain. Kaiser's engineers and Navy specialists launched a campaign of fixes. They prescribed preheating the steel before welding, slowing the cooling to prevent sudden embrittlement. New steel alloys, tougher and more flexible, replaced the weakest batches. X-ray inspections scanned every critical seam, catching hidden defects before a ship left the dock. Crack arrestor plates, heavy steel bands, were added at stress points, especially near hatch corners. Each remedy came from nights spent in labs and days spent on the line, balancing the drive for speed with the need for safety. By 1944, these changes had restored faith in welded ships, proving that science could keep pace with the demands of war. Between 1941 and 1945, American shipyards delivered 2,710 Liberty ships, each one a floating answer to the crisis that gripped the Atlantic. In Richmond alone, 747 hulls slid down the ways, a single city's output that dwarfed entire nations' wartime fleets. The secret wasn't just speed, but scale. Where the first Liberty ship demanded over 1 million man-hours, late-war builds needed less than a quarter of that. The sharp drop, nearly 75% fewer hours per vessel, freed up labor and steel for tanks, bombers, and the next wave of industrial challenges. The 10-minute trick, once a local experiment, became standard practice not just in shipyards, but in assembly halls and factories across the country. Welding replaced riveting as the backbone of heavy industry. Aerospace engineers borrowed modular assembly and rapid crew rotations to build bombers and rockets. Pipeline and bridge projects drew on lessons first tested beside the bay. By war's end, Liberty ships had carried 2/3 of all U.S. wartime cargo, an industrial feat powered by teamwork, innovation, and a willingness to rethink every step. The legacy of those 10-minute rotations endures, woven into the fabric of modern manufacturing and the memory of a nation that learned to build faster than it broke. Between 1941 and 1945, American shipyards produced 2,710 Liberty ships, 747 from Richmond alone, cutting average build time from 230 days to just 17 by late 1942. This leap was driven by innovations like the 10-minute rotating welding crew, first documented in Richmond Yard memos and newsletters from August 1942, which kept teams sharp and seams strong. Yet, some details, like who first proposed the method, remain unclear in surviving records. The results, however, are undeniable. A 75% reduction in build hours, safer working conditions, and a new standard for industrial teamwork. Welding, once a risky experiment, became the backbone of both wartime and modern shipbuilding. Today, assembly line principles and rapid training, first proven on the Liberty ships, shape factories worldwide. The legacy of one welder's 10-minute trick is measured not just in ships, but in every production line where speed and cooperation keep the world moving forward.